in 1926 and 1927, some new interesting ideas popped up into existence, and they were, I guess, initiated by a physicist whose name was Louis de Broglie, and he was in the group of physicists that really liked waves. He really liked waves. Einstein didn't like waves. He preferred particles and the particle nature of light. De Broglie, he didn't want to let waves to go off the hook, and he said, okay, if light or if an electromagnetic wave can behave as a particle, and you are saying that that's the case, then I'm saying that things that behave normally as particles, that why in the world couldn't they behave as waves? And if you are assigning momentum to waves, why can't I assign wavelength and a frequency to a particle? And he did some smart mathematics, and he showed that if particles could be described as waves, then these should be the wavelengths or the frequencies that you should measure. And the mathematics works out that for a regular, everyday type of object that we come into contact with, like for example this pen, okay, if you calculate its wavelength, it's so small that you can't measure it. So we can't, we cannot disprove de Broglie with everyday objects. But if you do the calculations for electrons, it turns out that the electron's wavelength comes out to, at the order of 10 to the negative 11 meters for the wavelength. And this can be measured. It's small, I know, 0.0000 and so forth, negative 11 meters. This is very small, but it can be measured. Today we have instruments that can measure such small wavelengths. And so some experiments were done in 1927 and then later on as well. And boom, we saw that electrons were really behaving as waves. How strange that seems. And so since then, we're talking about matter waves, that particles or pieces of matter can be described as waves. And for everyday objects, the wavelengths are so small that we don't see the wave properties of matter. We don't see ourselves diffract as we're running through the door. But we see electrons diffract as they're running through tiny slits. And you can see the double slit experiment, which Young first performed with waves, and he saw the diffraction of waves. You can do it nowadays with electrons, and you see that electrons diffract as waves do. And so, yeah, matter waves. Matter sometimes behave as waves. Strange, but exciting.